So recording the video during first period on Friday, so you guys can work a lot of it over the weekend, knock it out. You can do it in a day, 2 days, easily. Want to remind you that it says right here, as far as on the calendar, on the 24th and the 27th, you could get 3 more points if you turn it in those dates, because I'm just giving this to you, and your numbers you just received not too long ago, if not last class, I'm going to move that date to the 28th and the 29th. So the 28th and the 29th is still enough time for you to turn it in for 3 extra points if you so choose to do that. On the calendar it says collect box projects on the 30th and 31st. For my classes, I'm going to make that the 3rd and the 4th because, again, I was a little bit late with giving this to you. So if I go back to where the box project is, there's 3 things: cutting corners, boxes, and intro to box project. Here we go. The cutting corners looks like this. Now I had this actually prepared. I cut these out. I made the boxes so that you could see what they look like. You're just cutting out the orange pieces, folding up the flaps, and making it into a box. So for instance, if I cut out these 4 edges, the base of the box would actually end up becoming this right here. And then you just fold these flaps up to create the sides, and you would basically have a box that has an open lid. Okay, you with me? So your boxes will have an open lid. They'll just have a bottom and 4 sides. Okay? And what your goal is to do, okay, so as I'm looking at this right here, let me go ahead and scroll down, because these are different, obviously different box sizes that will yield different volumes. They will give different volumes because their dimensions are different. Okay? And right here you could see them flap up, fold up. You have a wide flat box, a tall narrow box, and sure enough, here are the dimensions, okay? So you could have a length of 18, 16, 14, 12, so on and so forth. Their corresponding widths are shown. You have access to this thing, okay? And I'm actually recording this as well, so that you can see what would the volume be. You with me? So when you see these dimensions of x, or 16, 10, and 3, you'd get 480. So on and so forth, okay? So what you're going to do is you're going to create these to where they're going to be, depending on the dimensions that I gave you in class last time. I have to give you yours before you leave today. They will be different. Your goal is to create this. So if you have a length of 22 minus 2x and a width of 16 minus 2x and a height of x, when you multiply all these together and put this in the calculator exactly how you see it, you will get some graph that you're then able to find the maximum volume for. Before you leave, we have about 4 minutes. I'm going to quickly show you what that would look like. Okay, so let's go to my calculator page here, and I'm basically going to put those pieces that are factors in the calculator that we were just looking at. 22 minus 2x, please don't put up. Add a page of graph, parentheses 22 minus 2x, times, that's very important on the calculator that you put that times, because it doesn't interpret multiplication all the time, and then we'll do 16 minus 2x, and then times x all by itself. It'll give you the volume as a graph. Okay? And notice that it doesn't show everything all at once. Menu, zoom, fit. So you can scroll down to A or press A. Let's let this fit on here. And then you can also alter it however you want. If you wanted to zoom in, like menu zoom 3, and let's say I think the volumes maximum is somewhere around here. Do you see where I'm going with this? I'm just trying to find what is that maximum, that vertex apex, if you will, on that curve. So from here I could say analyze the maximum, and I could say way over here to the left is the lower bound, way over here to the right is the upper bound, and immediately you see right here it shows this maximum display, and it looks to be 480. When x maximum will be realized. Do you understand? The way I just did this is what you will do with your dimensions, because with your dimensions you're trying to maximize this said volume. And you're trying to find where did that happen. Here it happened at 3.05, right? Do you understand what I'm saying? And that's what you're doing too with the dimensions that you have. Okay, so the dimensions, listen, so that you're clear, because I think there's a question right now. The dimensions that I gave you are what you start off with. If I gave you 10 by 5, that's what you start off with. You with me? If I gave you 19 by 17, that's what you start off with. And then you're going to cut the corners. You with me? You're going to cut the corners and build said box. I'm not going to give you too much because then I'm just doing it for you. But a lot of what I've already explained is the process of how you're going to do this. Go ahead. Yeah, Thomas.
So like basically all these things, like cutting corners, over this, he wants to do all these steps.
Okay, listen. I don't want you to do this sheet. You don't have to do this worksheet. Don't worry about turning this in. But I want you to do all the steps in order to do the project. This is only as an example, not for you to replicate exactly as is. Let me finish off with the actual thing that I'm looking at. I want you to do this. I want you to read these instructions, and it'll tell you exactly what to do. The rubric right here will tell you exactly how many points we're awarding for what. Okay? So don't think it was that worksheet. We just have to do that worksheet again. It's not that. The worksheet was to be an activity so that you could see what your project would be. Have a great weekend, guys.
If we forgot our dimensions, do you have the paper?
I do have it, yes.